Well, this is Pops anyway. I figured Debbie took a step out so she doesn't have to listen to me platter on here. She has a few times, but you know, it just she feels odd, which I would too. Guy talking to his tablet that probably 5 people in the next 10 years are going to see. But it's who I am, it's what I do. Oh, I got to write some stuff down here before I forget. But I figured I'd have a conversation after I got through talking today. Fella at Just a Few Acres Farm talking about taking sleeves out of his engine. And the style that Pete wants to use is good. Right? I'm not discounting that at all. If you have good equipment and a dry sleeve engine and you take it to a machine shop, and if they know the outside diameter of the sleeve, you bore 20 thousandths smaller or 10 smaller. In other words, 10 thinner. How should I say this? If you bore a sleeve 10 thousandths smaller than the outside diameter, you're only going to have 5 thousandths on each side. So you bore the sleeve 20 thousandths and you have 10 thousandths that you can peel out. That's pretty much a common accepted method how to remove dry sleeves. Bore them down through, peel them out, and then you've got a clear hole. However, going back years and having done this myself, there's one method that seems to work regular, and pulling does not work with a dry sleeve well at all. Just don't. But for one main reason, pulling might work in some occasions. There was a bunch of dry sleeves that Farm LH, Perkins, 3152s in particular, almost any Perkins, but Ford, that their whole Red Tiger series was all sleeves, except for an occasional. You would get one where they bored it for one use, and it's like, oh, that was going to be industrial. Need to block over here, and the block is at 4.1 for your 172 engine. No sleeve. But you got a lot of meat there to put a sleeve in. So, what was another one? Well, those are the main ones. Occasionally in automotive, but in automotive, that's a whole new world because in the past, a lot of them just put the sleeve in with a ledge on the bottom and drove the sleeve in to its location. Now what? Now you do have to bore it out or run a die grinder up a couple sides as thin as you possibly can and break that out. Don't use a thin cutter. You want to use a nice standard size 1/2-inch cutter. Grind, and it takes a while. Grind through it because you'll do very little damage if you go through. But you want to get it thin in 2 spots so that you can peel that one out and it loses its integrity. Then you'll be able to pull the rest of it out without too much trouble. Well, first in automotive, you want to be sure it even has a sleeve. That's problematic number one. When the sleeve's put in properly, if you go to JAMZ online, Jameson Automotive Machine Incorporated, you will find that if you put a sleeve in, it's hard to see that it is a sleeve, if it's a repair sleeve, because of the bore in the bottom. But to find it, the ledge bore in the bottom, the backwards counter bore, so to speak, instead of being up here with a rim, there's a little ledge down below left when you bored it out to fit the sleeve, and it sits. When you put the head down with the head gasket, it can crush the fire ring, and the sleeve is held. It's captured. Can't get out unless something bad happens. And by that time, you don't need it anymore. So dry sleeve in automotive, that's a whole different ballgame. But Pete wants to bore it out and peel it. It's a great idea. It'll work. Our Jameson Automotive Machine never did it in my world. Jameson Automotive, that's the only way they'll do it. And like I say, it's not a bad idea. I just get a little concerned sometimes because you're just like you grinding a groove in the sleeve. That tooling can wobble. There's a lot of stuff that can happen. But if you know your tooling and you know what you're setting up and how you've done, it works good. It's a lot easier on the block. However, what I want to discuss today is the one which if you want to bore it thin, you take the block out and take it to the guy to bore it. It's very rare. I used to be able to do it, and I'm hoping to be able to do it again, but I used to have a portable boring bar that I went on the road, and I could do those type of things. But most of the time, I was working on an engine that either didn't have a sleeve or sleeves came out of it. So what do you do to get the dry sleeves out? Well, not in every case. I'll get into something else. But the standard method is to turn the block upside down. You have a perfect fit, almost circular or fully circular driving disc. The outside diameter is approximately 10 thousandths smaller, 5 on each side for the disc to fit in. The finished, not sleeve bore, but the finished block bore diameter. You want about 5 thousandths clearance for a little fumble. If you got it tighter and you know it's going to work in there, rock and roll. Ledge bore it. Yes, you're going to put another counter bore on there so that there's a pilot that drops in the sleeve. And you want about a 1/4 inch of work, but you want at least a 1/4 inch that it falls into the actual sleeve. And there again, you want it about 10 thousandths smaller, so that all the way around, if you measured across, there's 5 thousandths on each. But 5 is less than you figure. This business card is at least 20. Okay? So it gives you an idea. You're still not talking a lot of space at 10 thousandths. Half of a business card. Total. Okay? On the outside, smaller than a block bore, and that inside pilot, just 10 thousandths smaller than the inside of the sleeve. Step number 2 in building this is even more important. You just found out that a 1/4 to 1/2 inch, and a 1/2 inch is great for one main reason we'll get into, but you want that plate total to be about 1 inch thick total. Why? Bounce factor. You want something solid and rigid so that when you pop it, it doesn't bounce. It's solid. Okay. Number 2. There are 2 ways to drive that. One of them is keep it solid. Don't put a hole in it. Okay. And you get a big driving mandrel, just like a mammoth punch. You want something that's over 1 inch if you're going to do it that way. 2 inches preferred. 1.5 inches is good. Big, heavy iron bar, large enough to get above the block, but you don't want it any longer than necessary to drive that sleeve out. Okay, the next step. You're going to put the block up in the air on hardwood blocks. Softwood works, but you want hard. Next thing, underneath those hardwood blocks, you want a solid base. Concrete is preferred, or a couple of I-beams or something heavy that can't move. Solid. Now out there I have a couple layers of 3/4 inch plywood that works. I've done it before, but that's even sketchy. You want heavy, solid, rigid. A bunch of I-beams with 1/2 to 3/4 inch plywood over it, laying down there with the block on top. And I mean I-beam stacked so the top is closed. The only reason the board is there is to protect the block surface and to have 1 or 2 holes in it so the sleeves you're driving can be punched out through the hole. All right, now you're going to pilot and hold the block in place. Now this is mass down here so that the block does not bounce. The wood will help cushion slightly, but that also takes power away from the drive. So even the wood, 3/4 inch, 1/2 might not be enough, and over 1 inch might be too thick. So you want in there that 3/4 inch range, which I know is 5/8 anymore. But if you can do it straight on good, solid hardwood blocks, oak, rock on, baby. Not short, long. Don't necessarily put long wise with a block, but you want them crosswise with the block to give you space to work in between, anchored together, and multiples if you can, anchored together, all as counterweight, and hard surface. You're talking about transferring energy. So if there's too many places this stuff can move, you've lost energy. Okay, so now we got the block upside down. getting ready to drive. Got a nice thick plate with a piloted shoulder, slides into the sleeve, and what's that for? That's so the outside you could turn down a little more, but you want that as large as you can, and it's on the inside. If this thing kicks up and out, it doesn't lock in the block, it might lock in the sleeve first. So that's why I say that pilot up to 1/2 inch, that'd be nice. Okay, number 2. So now you got your block set, it's upside down, it's on hardwood blocks and foundation, concrete, beautiful. Okay? Got a nice space in between. Your blocks are locked so they can't bounce. They stay in one place. You got your plate. It's in the sleeve. It goes through. You know there's no notches or anything else to catch. Crankshaft is not there. Camshaft is not there. Nothing else in the block, okay? You can do it, but it's not good. All right. You got a mandrel. Nice, big hunk of iron. You're going to say, wait a minute, it's a lot of mass. I'll just pick that up and slam it. 2 problems. One of them is bounce factor. That thick plate is there so it doesn't flex and bounce. The mandrel is big so it doesn't flex and bounce. Okay? And the next thing is a 5 or 6 pound short-handled maul. Or not maul, but sledgehammer head. You might be able to do it with 3, but less means more pounding. And the 6 with a heavy mandrel, you need enough to move the energy through the mandrel to the plate, to the sleeve. So solid deck, solid place block, solid steel block, solid mandrel, big dang hammer, pop, and you will actually feel the sleeve break loose. Once it does, you may be able to even just take the mandrel and pop it a few times later, but drive it right on out as far as it can go. You're on your way. Why driving and not pulling? Driving does 2 things. One of them is it instantaneously doubles or triples the force on that sleeve. It also, because of the blocks and the spread of the hardwood blocks, spreads the energy out within the block. You're not just pressing against the block deck surface itself. Number 2, even grade 8 or 120 threaded rod, it's not going to be enough. And if you get it in fine thread, you'll wear it out so fast you'll wonder what happened. The next thought after that, while you're popping it with the mandrel and things do not bounce, energy is transferred to the sleeve only. No extra force other than out here in the hardwood blocks on the block itself. And if you got them set up right, you're going to have the blocks on either side of the sleeve. And if there's no other protrusions, which you have to be careful of as well, you'll be able to drive that sleeve right down and out of the hole. A few good solid pops, and in most cases you'll be surprised. Now, International Harvester has certain sleeves that have to be pressed in. I can't remember. This is a guesstimate of what I remember. I believe Jim's Tractor Service said it had to have someplace in the neighborhood of 1,200 pounds force to press the sleeve into place, or they would come loose. You heard me correct. What am I going to do with a 6-pound hammer on that? You'd be surprised what a 6-pound hammer can do. Okay, last problem. You're trying to pull a drive sleeve out. What's the problem with that? Well, you're saying I got a 1,200 pound sleeve. I need to, in certain cases, you may need to put a plate on top, a whole plate, nice and smooth, on top of the deck, around the sleeve, big old hole in the middle, and you're pressing on the plate to spread out the energy. And you still may need to get underneath, put a mandrel against that bolt in the center, and pop that rascal to break it loose. And in other cases, yes, so you either bore it out or grind your little grooves in there. You say, well, grinding the groove, well, think about this. You'll need snap gauges or possibly an inside micrometer. Know the inside diameter of the sleeve that you have and measure. Figure out where you want to grind that groove, or two grooves. If you get one through far enough, you'll be able to pick the center of it out and take care of the whole problem, or it'll buckle for you. And you can measure, get the thickness of the sleeve in a tech manual. Okay? In Komatsu, we used to call them engineering drawings. And you'd get the outside diameter of the sleeve, the hole size in the block, the inside diameter of the sleeve, okay, outside, inside. Subtract the two, you get the thickness of the wall, both walls. What's left over, cut in half so you know it's only one wall. Confirm it. Take a bunch of feeler gauges underneath the block, or if you got a way to measure thickness down in there with a micrometer of sorts, then measure to confirm that that's the right thickness, and then grind through and leave yourself 10 thousandths, 5 or 10, and then you can make it buckle, or you give it a pop and the sleeve will come loose. So those are some ideas on dry sleeve, how to get them out. Farmall H, I bought the right Owatonna pulling disc, but it'll work on dry sleeves. And what did I use? For me anyway, because of space and what I had to work with, was I had a commercial forged sleeve tool. Big thick thing, beautiful ledge, perfect fit. Set it on there and I used a grade 8, I think 7/8 bolt. The larger the bolt the better. Big, 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 big. If you can bolt the two together, that's great. If you can't, then take the nuts on the top side, lock two of them together. Back one right up against the shoulder and the next one up to it. Slide that down through the hole and you'll be able to feel the alignment. You pull it a little bit, you'll feel one side of the disc come up. Set it in there so you know it's solid and firm. Now, if you really want to be careful about this, cover that with, don't tape it, but before you put the nuts on, put a piece of either fabric hydraulic hose, no metal in it, or heater hose over the top of that bolt. 7/8 preferred, 3/4 will work. Only grade 8. Never use grade 5. Use grade 8 or harder. Transfer of energy. Got my drift? It's a harder, solid bolt. Get it all in place, lined up where you want it. Now you got a rubber handle on. If nothing else, just a short section with a rubber handle. Then take your hammer and give it a pop. 6 pounds, bang. A mandrel, there's a better transfer of energy that may work for you, but I used to enjoy putting bolts on them the shortest possible to be able to get the thing broke loose, and then use a longer bolt. Once you run out of space, then put a longer bolt on, because the more sleeve that comes out, the easier the drive. Not always, and don't count on it every time. Why? As the sleeve goes up through, there's quite often material that goes with it. And you may not believe it, but between the block and the sleeve, each has carbon of some sort. And they tend to come out and just kind of cling to the sleeve from the heat. And they'll build carbon from the heat in the sleeve. And crap gets in there. Cast iron is porous, doesn't matter how you look at it. So a little bit of oil can go one way and a little bit of antifreeze the other. It doesn't mix, doesn't go anywhere. It just impregnates, and you'll have carbon between the block and the sleeve. You say they didn't clean it well enough. Could be. In some cases, it's not carbon. It's Loctite. And if you're really unfortunate, it's high temperature sleeve and bearing mount. Oh yeah, that makes some of that red stuff look like a patsy. So anyway, let's, on the dry stuff, dry sleeve engine, let's go back to the beginning. If it's automotive, there's almost 100% chance there's a ledge bore. So you're only going to do two methods. Boring bar and bore it out to within, say, 10 to 20 thousandths. And just leave a little bit of sleeve there that you can chip out. Or you're going to take a die grinder, you're going to figure out the external diameter of the sleeve and the internal, cut it in half, and then measure a groove down there about 10 to 20 thousandths that you measure before the outside of the sleeve. If you do that in one spot, you'll probably be able to take it out. On automotive, you'll probably have to do it in two. Now, go back to tractors with a ledge bore sleeve. Yes, top bore, counter bore, I should say, not ledge bore, counter bore. Turn the block, you take the block out, turn it upside down, hardwood block supporting the engine block, either side. Now, sometimes if you turn the blocks at an angle, you might get more energy transfer because more of the engine block is on those blocks because they're at an angle. But you still need that distance. It's mass as well as stiffness. The mass to keep things from bouncing, have enough energy that when you hit it, they don't want to go anywhere because they're too heavy, and they're on concrete or a plate of steel, even something. Next, you've got your disc with a counter bore or pilot to go in the sleeve. That is about 10 thousandths smaller than the inside diameter of the sleeve, new or whatever sleeve size it is. And the outside, 10 thousandths smaller, 10 to 20, smaller than the outside diameter of the sleeve. Put that in there with a mandrel, big dang mandrel, and a 6-pound hammer with a short handle. Pop! Get it broke loose. That's your standard for most sleeves. Perkins, Fords, Farmall H's, no problem. I think they're wet sleeves in the M and the C. Oh, don't worry about the littlest ones there, the Cubs. They're no sleeve. So don't even think about it. So that's for dry sleeve. Dry sleeve most often, once they're moving, you're golden, drive it right out. But be careful of the bounce. Always make sure that your mandrel or your bolt is in the center, that you know it's in the center, that you're not pulling it, you're not pushing it, you just know it's centered, and turn it. Each time you strike, turn it. Just an inch or a quarter turn, somewhere in there, so that every time you strike, it's a new place that hasn't been hit prior. In other words, say it's in line with a crankshaft, because some of them have two flat sides. But even then, you got a disc. Put a mark on it. Turn it 45. Turn it 90. If you want to turn it 90, turn it 90. Pop it the second time. Turn it 45 or 90 again. Pop it. Keep turning it. So a different part of the sleeve's hitting it, or disc is hitting in a different part of the sleeve. What's the idea there? If there's an imperfection, you aren't driving in one area. If something slipped, you have to pick it up and turn it. You can feel it, and you know it's not locked in the sleeve, it's not locked in the engine bore. Because as soon as anything feels stiff, you pull that out and clean up wherever there's a problem. Well, if there's going to be a problem, maybe. But think about this. When you pull the sleeves out, you're either putting a solid, rigid micrometer hone in there to clean up that bore, or the board's in pretty good shape and you're going to run a dingleberry hone and clean up the interior of it anyway. Just be careful and minimize any damage that might happen. Well, if I bore it out, you bore it out, you screw up, there's huge damage. Or as Billy Fusillo used to say, it's huge. I don't know why he said it that way, but he did. Sold a lot of cars, the idiot. But that's just one of the ways to look over your dry sleeve situation and do it at home. Wet sleeves, we've done it in tractors, and believe it or not, the same problem with trying to press them out with a bottle jack. Even with the right pressing disc and the whole nine, it picked the whole front end of the tractor up. An O-ring sleeve. Well, yeah, but what they didn't tell you was the antifreeze and the oil both causes the O-rings to swell. And because of the antifreeze, there's rust. You get my drift from there. I've seen some of those, you drive the sleeve out and the oil side O-ring just boom, falls out right off the sleeve, and sometimes in pieces. And that's not even why you tore it apart. And then rust around the other one, as well as sediment and other stuff gets down in there in the sleeve. So you always end up popping it loose while you're laying on your back trying to do this. When you're young, it's one thing. You start passing 40 doing stuff like that, you can do it. You'll figure out a smarter way to do it too. But once it's loose, then it'll pull out. Wet sleeves can pull out. Dry sleeves do not pull well. The only place they would pull well, maybe, is don't pull, turn it upside down, and make sure you have a wide enough saddle in your shop press with it upside down to start to push, not pull. Just a thought for later on for some people. And even there, I wouldn't do that unless I took the hammer, mandrel, or bolt, proper plate, and smacked that sucker to start it. Then pressing becomes simple. The shock load of the hammer does more than a constant load or press. Other things you're building until it reaches that point, and then bang! Okay, well, why not just keep building stuff on top of it, and you be the bang? Just a thought. And it's one that I've seen worked enough times. I watched an idiot do it. A literal idiot. Narcissistic, brain-dead monster of an idiot. Blow the sleeves out of a Perkins 6.354. Drive them right out, no problem. And put the other sleeves in and never clean up, never measure a thing. Drive them out, do a quick little wipe out, oil them, and drive the new sleeves in. Put her back together. That's not right. Correct, it ain't right. You want to check your bores. It's like they do at Jamsey Online. But you don't have to. It does work well without. But you're a farmer, that's what they sell is rebuildable. But dry sleeves, the block does different things. The thickness isn't perfect in that bore. So your heat areas are different in the bore. And because of the heat areas, the bore itself can be out around and tapered, plus the thrust. So there's a lot of ways that things can get out of hand, but at the same time, clean up the bore with a dingleberry hone and take some general measurements. Find out. It's worth it. And if you find out it's within a thousandths or two, and it's just everything's within spec, drive her together, check your bore again, ship it. Why do I say check the bore again? Because you're probably driving those sleeves in there. You'll say freeze them. Pick one. Pick one? Yeah. Pick one. You're going to have similar problems in different ways. You're going to have things that it heats different, buckles different, it moves different. You put it in the block, it conforms to the block, but what did that cold stuff do to it in the process? Yeah. When you drive it in, you're going to put oil on it. And oil isn't going to help you when you're doing the freezing thing with that liquid nitrogen. It may help to start, but what happens with oil you pull it out and all of a sudden the temperature starts rising and you're still at 300 degrees below zero. Maybe I'm wrong. You're still at 150 or 200 degrees below zero. What's that oil going to do? Yeah. The worst I'd ever put in any one of those is clean it up and spray some WD-40 in there. That's it. At least it's fluid enough to soak into the block and act like something when you slide it in there. Sounds crazy, but what do you think SAE 30 or 15W40 does at 100 degrees below zero, let alone 150 or 2? So just some things to think about when you're rebuilding your engines. I have seen many an engine just blown down, thrown back together, dry sleeve, and still run great. Anyway, that's that. Now, stand by because this has been a half hour long. I want to go into the electrical one. And we'll have a separate one there. Things I found out just today on a service phone call and a quick little service trip. See ya.